Alright guys, so here's your help video for your test on Tuesday for logarithms. The first section here will comprise about 10% of your test. There won't be quite this many questions, but I just wanted to include a whole bunch so you guys can see a variety of types. But altogether you're looking at about maybe probably like 2 of these, and that makes a total of 10% of the test. So what we're looking at for the first section here is want to make sure that you know your basic log properties that we talked about a little while ago, like the fact that this is 1 or the fact that this is 0 or the fact that this is x. Same thing here with this one. And also want to make sure that you guys are aware that the argument also has to be greater than 0. Okay, so let's go ahead and begin here. So in this case, since these match, the answer is 1. That would be this property up here on the top. Pretty simple. Pretty simple. Let's go ahead and move on to another one here. Next one. Now this one doesn't match any of those rules over there, but we're going to make it match. This has a base of 3, and I can get that to have a base of 3. You can rewrite it as 3 to the 3rd power. And then using this property here, we can basically just kind of cancel those out and realize that the answer is 3. Okay. Now another way you guys could do this if you're using calculators is you could do change of base. But I would kind of like you guys to be able to do it without a calculator as well, because that allows for some flexibility that's helpful in solving problems quickly later on. But either way works. All right, let's continue. Next one. This one looks funny because it doesn't have a base, but when they don't write the base, we just have to remember that it's a 10, and these cancel out, and the answer is x. That would be, once again, this rule. All right, next one. ln of 1 over e. Okay. So first of all, what I want you guys to remember is that ln is basically a log with a base of e, right? Also, we don't like fractions, right? I want these bases to match. So we got the right base, it's e, but it's 1 over e. We don't like that. And we can fix that if we just change that to an e to the negative 1 power. And by doing that, once again, we come back to that rule again where these cancel and the answer is negative 1. Here's another one. On this one, the bases match, but we don't like that square root there. And the way that we deal with square roots is we change square roots into half powers. And then once again, revisiting that rule for yet a 4th time, we find out the answer is a half. Let's go ahead and take a look at next one. For this one, the answer is, tempting to say it's 1, but it's not. The answer is no solution. It kind of looks like this one, but it's not. Okay? It's actually this one down here. The argument has to be greater than 0. So since my argument is 0, that's not greater than 0, therefore there's no solution to that problem. Let's go ahead and take a look at another one. Now this one is the one that matches here. No matter what your base is, if this is 1, then the answer is 0. This is another no solution because my argument is once again less than 0, but we need my argument to be greater than 0. All right, so that was the end of that section. Now we'll move on to another section on your test, and this is likewise 10% of your grade. You're going to be given a logarithmic expression, and your job is going to be to expand it. The properties that we're going to use for that would be the following. If you have log base m times n you can write that as two separate logs that are being added. If you have log base m over n, then you can write that as two separate logs that are being subtracted. And if you have log base m to the x power, you can rewrite that as log with an m being multiplied by that power. So before we start applying those properties, though, we want to do what we usually do, which is we want to rewrite those roots as fraction powers. So that 1/3 power there is going to be that third root there is going to actually be a 1/3 power.
Did I leave my note? Like, if you really yes.
And then what we're going to do is we're going to distribute this power in, and when you distribute that in, you're going to multiply it by the powers that are already there, which in this case are 1s. So it looks like this. So that's the first thing you want to do, is kind of take care of any square root issues or fraction issues that you might deal with. But now we're ready to apply the properties. So the first thing I'm going to do is I'm going to apply this property up here. I have three things being multiplied together. So what I can do is I can write that as three separate logarithms that are being added together. The next thing I can do on this problem is I can take the powers on the arguments and put them in the front as multipliers. So that would look like this. Now, the unfortunate thing is on this test, they're not going to write it like that. And we talked about that as well a little while ago. They're not going to leave it as 1/3 in the front. They're going to write it as one giant fraction. So I'll show you what I mean by that. The 1/3, the ln 11 is going to look the same, but the 1/3 ln 7 is going to be ln of 7 over 3. And the ln of 2 will also be over 3. So that's how they're going to write their answer on the test, just so you guys are in the know about that. All right. Keep going. Here's another one. So in this case, since I have a logarithm with two things being divided, we're going to use this rule here. And the order matters. So the one that's on top comes first, and the one that's on bottom comes second. And we subtract those. And then applying the third rule again, we're going to take the powers and we're going to put them in the front. So your final answer would be 3 log 6 minus 3 log 11. We'll also be doing the reverse of that, which is where instead of pulling the logarithm apart into two separate logs, we'll be putting the logarithms together into one single log. So first of all, for this one, to put them together into one single log, the first thing I'm going to do is I'm going to rewrite this as 1/3 log base 4 of a. Okay, and then what I'm going to do is I'm going to apply the reverse of rule 3 here, where I have a number in the front, but I'm going to move it to become a power on the argument. So this one's going to be rewritten as c to the second power. And this one is going to be rewritten as a to the 1/3 power. The next thing I'm going to do is I'm going to do the reverse of log, or this rule up here on the top. I have two logs that are being added together, so I'm going to put them together into one log where those arguments are being multiplied together. So I have log base 4 of c squared times a to the 1/3. Now this is technically a good answer, but I think it's likely they will write their answer like this on the test. They'll change that 1/3 power into a third root, just so you guys know. Okay. Take a look at another one. And this is another section, by the way. This is another 10% of your test. 2 questions like this. So let's take a look at another example. Here's another one. So I'm going to apply rule 3 here. I'm going to take the number in front and make it become a power. So put that there, and you end up with ln of 12 to the 3rd power minus ln of 11 to the 6th power. And then I'm going to apply the second rule here where I take my two logs that are being subtracted and I put them together into one log where the arguments are being divided. Remember, the first one goes on top and the second one will end up going on bottom, and that will be our final answer there. Okay, so that's 30% of your test right there, all those things. Let's move on to another expression, or another problem. This one's only 5% of the test. You'll have one question like this. It says, rewrite the following expression using the change of base formula. So that would be log 50 over log 6, and that's all you have to do. Bang. Pretty simple. Okay. Next one, evaluate the following function at the indicated value. So here's my function, and we want to find out what's f of 4. So what that means is we're going to be plugging 4 in for x. And that would look like this. Okay, so to do these problems, you're going to end up having to round your answer to thousands because we are going to be using calculators for this. The first thing you do is you're going to go ahead and just do the change of base on that piece there. And then punching that into my calculator real quick. I'm getting 1.262. After that, we're just going to do the multiplication and subtraction. So let's start with the multiplication. I'm going to multiply that by 4, and I get 5.047. And then if I subtract from that 10, I get, as my final answer, negative 4.95, rounding to the nearest thousandths is 3. Okay, so that's how we'll be doing evaluating. Okay. Move on to a new section. This will be worth 20% of your test, which means I'll have about 4 questions like this. All right, so this part of your test is 20% of the test. Probably gonna have about 4 questions related to solving logarithms equations. So we talked about a few different types of log equations. This is the type where you have a log on both sides. So in this case, you're just going to go ahead and take off the log on both sides. And then from there, you just solve it like you normally would. Simple equation. And we get negative 6. Remember, your answer cannot make the argument 0. So if you were to plug in negative 6 here, right? We're good there. It's 18. That's not 0. So if we plug in negative 6, this log's okay. It also has to be okay for this one. If you plug in negative 6 here, you get 18. So remember, your answer cannot be something outside of the domain. It can't be something that makes the argument false, or negative or 0, I mean. Another way you can do it is, instead of just plugging it in, the way we talked about it in class is you take the argument, right, you make it greater than 0, and you solve. And when we're going about this approach, you've got to be careful that when you divide by a negative, you reverse your inequality. So any number less than negative 1.5 is a good solution. And then you have to do it for both of them. Once again, we reverse the inequality because I divided by a negative. So long as my number is less than 0 and less than negative 1.5, we're good. And this number is less than both of those, so that's good. So there's two ways you could do it. You could actually find the domain, or you could just take your answer and plug it in and make sure it doesn't make any of the arguments 0 or negative. Right. Let's see. So let's take a look at this problem. So this is one where we have a logarithm, only one log, so we can't just cross it off. In this case, what we're going to do is we want to get the log by itself. So this piece here, I want to get that all by itself. So I need to get rid of that 4 and 3. You might be really tempted in the way that they've set this up to subtract these, but that is not what you do. What you're going to do is you're going to add the 4 on both sides. And after that, you're going to divide the 3. Once you have the log by itself, you're good to exponentiate both sides. So that's where you take the base, right, which is 11, and you make that the base, and you make this whole thing here become a power on that base. And that's what we call exponentiation. Okay, and the reason we do this is because now this and this will cancel, leaving us with negative 6a minus 9 equals 11 to the third power. So now whenever you get a number like this where it's really big, they will probably just leave it as 11 to the third. So that's what I'll do in this case, but they may not. You know, they may actually go ahead and figure out what 11 to the third power is, but for now I'm going to go ahead and write my answer like this, and then we'll see how this software is writing the answer. So anyway, we can do this. This is fine. Okay. However, I do want to see how they wrote their answer on software real quick so you guys can kind of be aware of what you expect. So let's see. Make some space here. We're going to need that space to see the answer. All right. Oh, looks like they actually worked it out. So then what I would do then instead is backtracking a little bit here. It's minus 9. I mean, there's a couple ways you could handle this. You could just get the answer right from here if you wanted to. But honestly, if I knew that they were going to have the answer in this normal way, what I would have done is I would have taken a moment to go ahead and just figure out what 11 to the third power is. So let me grab my calculator here real quick. And that comes out to be 1331. Then I would add 9. And then I divide by 6. So something tells me 6 is probably not going to go in there evenly because I'm looking at the final answer here. So they probably just reduce it to become that. And that's the final answer. So okay, so let's go ahead and move on. Look at another one here. So now this is the third type of log equation. So we saw the first one was a log on both sides. We saw on the second one there's only one log. Now this one has two logs, but they're on the same side of the equation. And when that happens, we have to use our properties that we talked about earlier. So I'm going to combine these two logarithms into one. When you have two logs being subtracted, you can rewrite that as one log where their arguments are being divided. And once you have rewritten that as a single logarithm, then you're good to exponentiate. My base is 3, so I'm going to write a base of 3 with this whole side here as my exponent. And whatever you do to one side, you do the other. So I'm going to use a base of 3. And this side becomes my exponent as well. And over here, these cancel, leaving me with 5 over negative 3x. And over here, 3 to the third power is 27. Okay, so how do we solve this? We're going to multiply both sides by the denominator. Okay, so in this case over here they cancel, leave me with 5, and on this side over here, what do we end up with there? It's going to be 1 greater than 2, 81. 81 it looks like, negative 81x. And then one more step, I would divide both sides by negative 81. And there's our answer, 5 over negative 81. Okay. All right, here's our next one. Same type of question, but different operation. This time it's plus instead of minus. So whenever you have plus, you could rewrite those two logarithms as one logarithm if you take those arguments and multiply them together. So I'm going to distribute this 2 into that argument over there to get this. And now that I've done that, I'm going to go ahead and move on to the next step, which is to exponentiate with a base of 4. These cancel. And we're pretty much home free after that. So dividing both sides by 2, we get x equals 3. And once again, you know, if you don't see your answer there, and it says no solution is one of the choices, you might want to be really careful to make sure that that answer that you got doesn't make the argument come out false, or 0 or negative is what I mean by false. So, but if you don't see no solution as an option, then I wouldn't even really bother checking that. It's not needed, obviously. Let's go ahead and take a look at the next one here. Now this is a whole different thing. This is another 20% of your test here. These are exponential equations. So when you want to solve an exponential equation, what you're going to do is you're going to log both sides. And the reason that we do that is because we have a log property that tells us that if you have an argument with an exponent, you could take that exponent and put it in the front. In this case, since the exponent is the x value I'm trying to solve for, that's a good idea, because now that that x is being multiplied with the log, I can get that log out of there by dividing it. And then from there on out, it's a calculator problem. So we're going to get log 83 divided by log 14. And I'm getting 1.674. Okay. So that's the main idea in how you solve exponential equations. Let's look at another one. Not a whole lot different here, but we're going to log both sides once again. We're going to take our exponent, we're going to put it in the front. We're going to divide the log out. Calculator time. So log 85 divided by log 20. 1.483. And from there, we're just going to go ahead and do our basic algebra to solve the rest of it. Divide both sides by -4. Final answer comes out to be 0.954. Okay, next one here. So what makes this problem a little bit different is that there's other numbers other than just an exponent part. Like, so in this problem, the one before it here, we had a base with an exponent, right? And then the one before that, we had the same thing. We had a base with an exponent. And so when you have a base with an exponent, all you have to do is log both sides and you're good to go. But with this next question here, I do have a base with an exponent, but I've got other stuff too. And so we need to get rid of that other stuff first. So I'm going to start by minusing the 8 on both sides. What would that be? -80. Then I'm going to divide both sides by a -3 to cancel that 3 out. And we have a decimal situation on our hands there, so 80 divided by 3 is going to be 26.667 approximately. Now I've got a base with an exponent. Now we can go ahead and log both sides. So I'm going to say log of 15 to the r is equal to log of 26.67. We can take our r and put it in the front. We could take this log and divide it out. And so my final answer will be whatever that comes out to be on my calculator. So I'll go ahead and punch that in really quick. Log of 26.667 divided by log of 15. Coming out to be 1.212. Okay. All right, moving along. This problem is pretty much the same, so I think I'll go ahead and skip that and let you guys handle that one. Word problems, I'm not going to have you guys do the word problems. We didn't get enough time to really focus on those in class, so we'll go ahead and just leave those off. You can skip them. The last thing we're going to look at is graphing. That's our last lesson that we covered. So we'll go ahead and begin. For these questions, you're going to be asked to state the domain and then graph the function. The questions where I ask you to tell me the domain of a function, that probably makes it only like one question on the test. And as far as graphing the function, I'm pretty sure it's going to be, let's see. Oh, maybe there's 2 questions of each, actually. 2 questions of each. So we'll go ahead and begin. So what we talked about with graphing is the first thing is you do want to start by finding your domain. Your domain is what you get whenever you take the argument, set it greater than 0, and solve. So x has to be greater than 2, which means that I'm going to be plugging in numbers for x that are greater than 2. But when you do, remember to put a little bit of distance between your x values. You don't want them to be really close. Otherwise, it'll be kind of hard to determine the correct shape of the graph because these graphs grow very slowly. All right, so at this point, what you're going to do is you're going to go ahead and plug in the 3 for x, and you're going to plug in the 10 for x, and you're going to solve. So I'm not going to show my work for that. I'm just going to go and put the answers because we've already done that earlier in the video when I asked you guys to evaluate. But I'll just go ahead and put up my answers here real quick. All right, and then for part C, we're ready to go ahead and graph this thing. So To graph it, you're going to start by graphing your vertical asymptote, which is determined by the domain. It says x has to be greater than 2. So I'm going to put a vertical line here at positive 2. And then I'm going to plot my 2 points. We have 3, 0 is one of my points, and we also have 10, negative 3. I'll just say that's 10 over there, and then negative 3 down here. So like that. And then we have to connect those dots with the appropriate shape, which would look like that. You have 4 shapes to choose from. I put them on your notes for this lesson, and that's how you can tell how to connect the dots. All right, let's go ahead and take a look at maybe one more of these. Let's go ahead and take a look at an LN graph. So for A, domain 2 minus x needs to be greater than 0. And I do need to divide by a negative 1 to get that x by itself completely. And 2 things happen. The negative 2 becomes positive, and the inequality is going to get reversed because I divided by a negative. So that means I need to pick values for x that are less than 2. So I'll pick 0 and then another number less than 2, maybe really far away from that would be maybe negative 8. Okay. I'll show my work for this one a little bit just to kind of help you guys out a little bit because it is it's a little different because ln. So first of all, for ln, if I plug in 0, I'm going to have ln of 2 minus 0, right? Now ln of 2 minus 0 is just ln of 2. And here's the cool thing about these ones. You don't need to use the change of base. You can actually just push ln of 2 on your calculator and get an answer. So ln 2 is 0.693. So we're going to have to round when you're graphing. The most accurate you're going to be able to get to is probably like the 10th place of that. So there's that one. And then we're also going to go ahead and we're going to plug in the negative 8. Got to be careful here. Notice that we have a subtraction sign, right? That's what that thing is. But we're plugging in a negative 8, so you have double negatives. So watch out for that. I saw a few people missing that in class, and they only wrote 1 negative and we're getting the wrong answer. 2, and that becomes plus 8 would be 10. And once again, we don't need to do change of base. We can just push ln of 10, and we can get 2.3. All right, so now we're ready to graph. So once again, we're going to start by plotting our asymptote at 2. We're going to plot our point 0 and 0.7. I don't think I'm plotting that right. 0.7 would be like here, actually. And then negative 8 and 2.3 would be like here. And the way you would connect those dots to get the appropriate shape would be something of that nature. Okay. And that is that. I'm pretty sure that's our last question. Let me make sure. Yep, that's it. Okay, so hopefully that was helpful, and we'll wish you guys luck on your tests Tuesday.